this video, we are going to continue discussing how to calculate solution concentration in the units of molarity, percent volume, and percent mass. So we've already discussed the definition of molarity, which is the number of moles of solute per liter of solution. So we could answer the following question as a review. What is the concentration of a solution that has 2.34 moles of sodium chloride dissolved in a half a liter of solution? So you might find these brackets. Chemists use these brackets to show concentration. So you would read this as the concentration of sodium chloride, and you assume it's an aqueous solution. And molarity would be moles per liter, so it's 2.34 moles divided by 0.5 liters, and so that would be considered a 4.68 molar solution. So we could figure out other problems, such as how would you make 300 milliliters of 1.5 molar hydrochloric acid solution. So we would have to know how many grams to use, since our scales only measure in grams, they don't measure in moles. So we would take our problem, our equation, molarity equals mole of solute per liter of solvent, and we would just plug in what we have. So 1.5 molar is the molarity, so 1.5, and molar is moles per liter, so I'm going to put mole over liter, equals the moles of solute, which is what we're looking for, x moles of hydrochloric acid per liter of aqueous solution. And it would be 0.300 liters. And that would be so because 300 milliliters converted to liters, you just move the decimal 3 places to the left. So to get x by itself, we're going to multiply both sides by 0.300 liters, 0.300 liters. Liters cancels, and I've already done this. 1.5 times 0.3 is that's going to cancel. So x equals 0.45 moles of HCl. And because we are being asked to make it, then we're going to have to convert from moles to grams using stoichiometry. So moles of HCl times 1 mole is, you have to go to the periodic table and add 35.45 is chlorine plus 1.08, so that's 36.45 grams. And so the math would be 0.45 times 36.45, and that's 16.4 grams of HCl. All right, another problem that we might have would be what's using percent concentration by volume. So alcohols, like this rubbing alcohol here, as you can see, if I show you, it says 70% by volume, and I guess if it's much more, it's really volatile and it could disappear quickly, and or it might be a little bit too reactive. So 70% is kind of the magic number. And so percent volume is often used to prepare solution, and is calculated by the volume of solute divided by the volume of solution. And because it's a percent, it's times 100. So note that the volume of solution is both the volume of the solute added to the solvent, so those two together. So if you wanted to prepare a 70% alcohol solution, you might use what's called a volumetric flask and measure out 70 milliliters of isopropyl alcohol and add water until the level goes up to 1,000 milliliters. So you would really only have 300 milliliters of water added to that, and it would be 70%. So a problem that you might see if you make an isopropyl alcohol solution by adding water to 70 milliliters of alcohol until the final volume is 450 milliliters, what is the percent volume? So percent volume is the volume of the solute, so that's 70 milliliters, divided by the volume of the solution times 100. So I guess you can't really see that. It's helpful to see it. So that's 70 divided by 450 divided by times, 100. That is a 15.6% alcohol solution. Or you might see isopropyl alcohol, methane, ethane, propane. It's C3H 1, 2, 3, 4, 5, 6. I think it's 6O, something like that. You would see something like that equals 15.6% concentration. We can also look at concentration in terms of mass. So the percent concentration by mass would be the mass of the solute divided by the mass of the solution times 100. And remember that mass of solution is the solute plus the solvent. So one example of this would be, so far with percent volume, we talked about liquids. You could also talk about that in terms of gases, fluids in general. But percent mass, if you have a solid, percent mass might be a better unit to use. So if we have an alloy is prepared by adding 15 grams of zinc to 65 grams of copper, what is the mass percent of zinc? And so we would just take percent mass equals the mass of the solute, which is 15 grams of zinc, divided by the mass of the solvent and solute, or the mass of the solution. And so the mass of the solution, equals 15 grams of zinc plus 65 grams of copper equals 80 grams. And so I'm going to divide that by 80 grams times 100 equals 15 divided by 80. Clear. 15 divided by 80 equals times 100 equals 18.75% zinc. So the majority of that would be, that alloy would be copper. Okay, so you might also find another unit of concentration as parts per million in the world of the environment. If you go into any sort of environmental science, hydrologist or air quality specialist, then you would be using this unit very frequently. ppm is parts per million, so it's parts of solute or toxin in many cases per million parts of solution. You also might see parts per billion. So an example is, according to the Safe Water Drinking Act, if you were to go to that website, then the standard level of lead that is acceptable is 15 parts per billion. Anything higher than that is considered unsafe to drink. So lead leaches out of our water pipes, and I think it's something like 20 to 30 to 40% of the lead intake comes from water. The majority of it comes from air, breathing in lead from lead paint. But anything above 15 parts per million would have to go through an entire protocol on fixing it or remediation. So that's one practical use for that concentration. You can work on problems on classwork 10.2 solution dilutions worksheet. Anything that we haven't gone over dilutions, you'll get that in the next video.